Hello, this tutorial will guide you through calibrating your lenses for scale bar integration and measurement annotations. Be sure to check your calibration occasionally to ensure accurate measurements and recalibrate following the instructions provided in this video and the user manual. Let's get started. First, make sure the microscope is powered on and connected. As usual, begin by connecting to the microscope's COM port and camera, then enable auto exposure in the camera settings. Then, initialize the microscope by pressing the home button. Next, take the calibration slide provided in the accessory box. You can illuminate it from below using either the curved illumination or spot illumination, as shown here. Remember to turn on the light source using the touch switches or the graphical interface. The microscope comes with 3 lenses. Please note that only lens 1 and lens 2 are compatible with calibration, while the third wide-angle lens is not. You can also apply this calibration process to any additional compatible lenses you may purchase later. Now, let's begin with lens 1. After homing the microscope, select Absolute Control Mode in the software. Enter 100 mm in the input box and press one of the control buttons for the C-axis to move the camera. We will move the camera axis to its 100 mm, 50 mm, and 0 mm positions, respectively. For each position, we will focus on the pattern and measure its pixel length to populate the calibration table. Once the camera axis is positioned at 100 mm, focus on the pattern using the Z-axis and align it using the XY rotation stage. Do not change the position of the camera axis during focusing and alignment. Next, go to the Annotations menu and select Calibration. Measure the pixel length of the 1 mm pattern. For better measurement accuracy, you can decrease the line thickness and change the color of the annotation from the Settings menu. We also recommend using the full screen preview. Take the first value, which is 202 in this example, and enter it into the table. For the calibration, we are not concerned with the vertical axis of the measurement rectangle. Now, repeat the same steps for the 50 mm and 0 mm positions. Note that as the camera axis position decreases, the camera moves farther away from the lens, resulting in increased magnification. Also note that your values may differ slightly from what is shown here due to manufacturing tolerances, but they should be comparable. Let's now repeat the same steps for lens 2, which is the high magnification lens. This lens has a very low working distance of only a few millimeters, so you may need to manually lower the camera module. Afterward, you can use the motorized Z-axis for precise focusing. As with the previous lens, move the camera axis to its 100 mm position. For this lens, the 1 mm is too large for its maximum zoom. So we will use 0.4 mm as our reference unit. For this lens, you should move the Z-axis very slowly. Otherwise, you may quickly lose focus. If your reference pattern is 0.4 mm, be sure to enter this value into the unit input box. You can also create separate calibration datasets with different reference units as needed. Once you have entered all the values, or any time you change a parameter, remember to save the data by exporting it to a file. You can create new files or overwrite existing ones. If the microscope is used in a multi-user lab, we recommend communicating any changes with your colleagues or creating your own calibration data. Also, remember that you can assign custom names to each lens dataset. For instance, if you have separate data with different units, you can easily distinguish it by giving it a unique name. When you change the lens, remember to select the correct calibration data, as the system does not automatically recognize the lens. You can validate your calibration by measuring the pattern using rectangle or line annotations for any arbitrary camera position. For easier focusing or alignment, you can always use the digital zoom function and return to the default preview by clicking on the zoom icon. Please also note that the calibration is optimized for measuring small dimensions, usually a few millimeters or less. When zooming out by moving the camera sensor closer to the objective lens, measurement errors can increase, especially for camera axis values larger than 100 millimeters. for instance, while measuring larger distances like centimeters. For samples with bigger features, we recommend creating new calibration data with a larger reference unit, such as 5 mm instead of 1 mm. In addition to lens calibration, each hardware module of the system can also be calibrated and configured from its built-in calibration menu. This menu can be accessed from the serial terminal of the software. For example, you can calibrate the angle sensor of the tilting module, or change the sensitivity of the joystick controller for each motorized actuator. For more details on advanced settings, please check the user manual or contact us. Thank you for watching. We hope you found this tutorial useful. Be sure to check out our other video tutorials and feel free to reach out with any feedback, and let us know what features you'd like to see in the future. Until next time, goodbye.